Ladies and gentlemen, a very good day to you all. Welcome to the presentation on microwave oven, which is developed through embedded technology as a part of our project on MRTech's internship program. In this presentation, we are going to have a very basic information about microwave oven and the embedded systems with its core principalities, which will be explained further as we proceed through this presentation. And now let me begin this by introducing our team to you. Our team consisting of two members, I, Doseti Navin Kumar and my friend Lavanya. We both worked together in this internship program and we have developed this project as an outcome of our internship program. Now, to give you the overview about the project, let me explain you the very basic requirement uh, of this project. Generally, in our houses or anywhere else, while the process of cooking, we do require different flames. There will be certain recipes which will require low flame, and there will be certain recipes which do require medium flame, and certain recipes do probably require most high flames. And for such classified requirements, depending upon the amount of flame required, here in this microwave we will be having three different flame modes. And those are as micro, grill, and convention. And here in micro we will be having the low flame, and in grill we will be having a medium flame, and in convention generally we do get a high flame. And this microwave oven is developed using the PIC16F 877A microcontroller, and we will be have a sound knowledge about this microcontroller also in the succeeding presentation slides. Now let's get deeper into this. But before that, the goals of internship must be explained. Generally, in internship or in any program, there will be certain aim or certain objectives that must be learned by anyone who is involved in it. And here in this internship program, we have been taught some basic programming syntaxes and functions, especially in the C language. Particularly in C language, we have been taught the syntaxes and the essential functions. And after that, we have been thought about the embedded systems, the definition, its area of application, and we also have been thought about the microcontrollers. Along with that, we have been given a clear differentiation between the microcontrollers and microprocessors, their area of applications, and everything henceforth. And together with this, we have been given an overview of embedded programming through various examples. And after that, we have been introduced about characteristics liquid crystal display, which we often use, and how it works, how it can be used. These are all things that we have been taught. Now under this banner of micro oven project, we have learned practical and embedded programming knowledge, and through the knowledge that we acquire, we have developed this project. Now moving further, as promised earlier, we are going to have some knowledge about the PIC16F 877A microcontroller. Here it is displaying the block diagram of PIC16F 877A microcontroller. Now before this, one must know the differences in between a microcontroller and a microprocessor. Generally, a microcontroller is a single silicon chip which consists of internal memory, I/O ports, additional hardware along with CPU, whereas in microprocessor, it is also a single silicon chip which is equivalent to CPU. It consists of ALU, CU and registers are also. Here in microcontroller, it does not need external peripheral devices like memory, I/O or other peripherals. They all are inbuilt in it. Whereas in microprocessor, you do require external memory and to perform specific tasks. So when we look back at the microcontroller, it is an independent core component, whereas a microprocessor is a dependent core component. Here we are having the very essential things that we require. That means we do not require any external peripherals like memory, I/O. So here it is a microcontroller. The PIC16F877A is a microcontroller. Here it is having the following components. It is a 40-pin dual inline ceramic core with the 40 pins as follows. This has been classified into port A, port B, port C, port D and port E's. Port A is consisting of 5 pins, sorry 6, and port B is consisting of 7, 8, port C is consisting of 8 again, port D consisting of 8 and port E consisting of 3. All these constitutes, and along with these um, some additional hardwares, we have parallel slave ports, we have voltage references, we have comparator, we have universal synchronous and asynchronous receiver transmitter, we have 10-bit analog digital converters, we have timers, timer 0, timer 1, timer 2 as classified, we have the memory and all these essential things. When it comes to memory, we are with a classified memory hierarchy. In PIC16877A microcontroller, the memory organization is being classified into 3 sections. Here we do consisting of program memory, and we also have data memory. Along with these two memories, we do have data, EEPROM and flash program memory. This is all about the block diagram, and when we go further, the entire process that we do, that the project will be done in a simulator, and the simulator that we use here is PICGenos, and we do compose a code and that is being embedded into it, and it is run as many times as we require, and the values are noted and being verified, and ultimately so that we can check the results that have been obtained are valid or not. In this way, the simulator is being used to simulate our results and to do experimentation as many times as we need. And this is the whole purpose of the simulator. And moving further, let's see what embedded system is. As the definition clearly suggesting, embedded system is a combination of both hardware and software. We do generally compose a code, which here always called as a firmware, and after the firmware and after developing a code, it is embedded into the firmware and it is integrated with the hardware to do a specific one or few highly focused jobs. In this way, embedded systems works. The embedded system is always different from general purpose computing systems in many ways. In general purpose hardware, it is always used general purpose hardware in general purpose computing systems, whereas in embedded systems we do use specialized hardware. The examples for general purpose computing system is Intel and AMD, whereas for embedded systems it is Qualcomm and Snapdragon. Here in general purpose computing systems, the applications they may be altered by the end user, whereas in embedded systems the application can never be altered by the end user. Here in general purpose computing systems, the responses are not time critical, whereas in embedded systems, responses are always time critical. If the responses are not obtained in time, they may lead to fatal conditions depending upon the application that we are using it. And in general purpose computing system, execution behavior is need not to be deterministic. That means we do not need to determine the behavior that is it is going to exhibit. It may be a random outcome which may come. Whereas in case of embedded systems, the execution behavior is always determined that it must give us the required output that we are aspiring to get. And in general purpose computing systems, again, the performance is the key deciding factor. Here in embedded systems also, the key deciding factors are a lot many there, which includes size, speed, cost, performance, and power consumption, etc. The example for general purpose computing system can be considered as a laptop, whereas for embedded systems, we may give mobile as an example for that. And depending upon the domain and depending upon the requirement, we do use the embedded systems to wide areas and in greater applications. If it is about time saving, if it is about life saving, if it is about efficiency or for security, in order to reduce manpower and for safety, for medical applications, cost reductions, and all such things, we do completely rely upon the embedded systems. And this is the significance of embedded systems anywhere and everywhere. And now, to move further, in embedded systems, we will be having 5 components in the architecture, which are as follows. The essential component is the system core, which may be a microcontroller or a microprocessor, depending upon the specific requirement that we will initiate. And we will be having input ports, which is unidirectional, and we will also be having output ports, which will be also a unidirectional one. And we will be having memory, which is bidirectional, which may be bidirectional in the sense we can give commands to the memory. That means we can write to the memory or we can write back from the memory to the core systems. And we will be having other devices which may be other peripherals that we can integrate with the core system to that, so that we can communicate with them. This is about the architecture of embedded system. And moving further, the overview of the project must be explained to you. The project consisting of 3 essential steps, and those includes the development of code, which means writing a suitable code that performs and executes our operation which we are aspiring to do. And then we will include the tools that we have been used, and the tools may involve hardware and software requirements that are essential to run the program. And the final part of the project is the implementation by using all the domain knowledge that we have acquired. And the rest of the presentation will be explained by my friend. Thank you.
I'm going to explain how the program is executed and to observe the simulation of microwave oven, which is a project of the internship MXC Technologies. So this is the code we built to run the microwave oven. So here this is the main function, main folder, and this is the header file. So in the header file, I have extracted clcd.h, matrix keypad, timers.h, and I have defined some functions like power on screen, menu display screen, grill mode, micro mode, connection mode, start mode. So these are all I have defined here in the header file. Now coming to the main file, we can observe here the coding. We can see this, the function time display screen function. This function is used to display the time we required to run the microwave oven. So in this time display screen, while the microwave oven is running, we can use the keys start, pause, stop. So this is about the time display screen function. Next, screen clear screen function. This function is used to clear the screen of previous data to display the present running data. So we will use to avoid the clashes on the screen display using this clear screen function. Next, power on screen function. This function is used to power on the microwave oven. So here when we are starting the simulation after building of code, we can initially observe the powering on of the screen and we will observe power on microwave oven. So next function is menu display screen. This menu display screen is used to display the modes we have. So here the modes are taken as the menu. So we have the modes grill, micro, convention, three modes we have. So next, void set temperature function. This set temperature function is used to set the required temperature. This is used in the while running the convection mode. We will use a set temperature function. Next, finally, set time function. This set time function is used to set the time we required to run the microwave oven. So, these are the functions we have defined to build the code. So, now we will see the simulation process. Here we will go to the simulation. So, when I am starting the simulation, before starting the simulation, I have to build the code. After building the code, I have to open the PixSimLab, and from here I want to load the builded code, and then we will see the simulation. Here powering on microwave oven. Using the power on screen function, we will get that. Now using the menu display screen function, we will here able to see the micro mode, grill mode, convection mode. Okay guys. Next, to observe the micro mode process, we have to click the matrix keypad 1. So we can see now the working process of micro mode of microwave oven. So here I have to set the time. I will set the time for 30 seconds. No. I will set the time for 25 seconds. No. To clear the 30 seconds, I have to use star key to clearing the 30 seconds time. Okay, now I will set it for 35 seconds. Here you can see the variation. Here the 35 is displaying. So now to start the working, I have to enter the hash key. So now we can observe the macro mode is started running. In this way we can observe that fan is rotating and the timer is running. So in this way we can say that micro mode is started its process in microwave oven. So here we have other options. Pause. If I click the matrix keypad 5 key, then the working of microwave oven is interrupted. You can observe that the rotating fan is stopped and the timer is off. So this pause button is used to interrupt the working of microwave oven. And now to continue the process, I have to click the matrix keypad 4. So here we can see that the fan is rotating and the timer is continuing. And finally, by clicking 6 on the matrix keypad, we can stop the working of micro mode. So here the time up, the fan will stop. This is the process of micro mode. Now we will see the grill mode. By selecting 2, I can observe the working of grill mode. So now here we have to set the time. I will set the time for 30 seconds. Okay, here also same star key is used to clear and hash key is used to enter. So now I will press the hash key. So my grill mode is started working. Here we can observe the fan is rotating and the timer is running. So in this way we can identify that the grill mode is working. So again by clicking pause I can stop the working of grill mode. So in this way again to continue I will click the 4th key. So in this way we can observe that this grill mode is running. So next we'll wait until the time up. Okay, in this way we can observe the grill mode working. So the time is up. Next we will observe the last mode, that is nothing but grill mode. This convection mode. This convection mode is different from above two modes. Here, by pressing key 3, I can observe the convection mode. To run the convection mode, we have to set the temperature here. Initially, I have explained in the code. So, now I will set the time for 30 seconds. By pressing hash key, I can start the process of convection mode. So here we can observe that the preheating was started from 180 seconds because I have initially defined in the coding in the set time for 180 seconds to run. So in that way the working will be started in the 180 seconds. Here we will see, wait. While loop. Yeah, here we can see that the while loop function. So as we defined that, now the time is 120 seconds, 180, 117. So we have to wait until it reach the 0 seconds. After that we can set the time and the convection mode will be started. So in the time I want to give some explanation about this PIC16F877A microcontroller board. That is, you can observe here so many parts are internally interconnected. So here we can see that LEDs of port D and port B are connected with port D and port B. So here by using these buttons we can blink the LEDs by oning our port D or port B as required. And also this is the matrix keypad. This is used for to give the input to the microwave oven. And also here we can see the relays, relay 1 and the relay 2. And also here we can see the real time clock. And also here we can see the serial ports. And also heater. And also here we have the 3 interrupt buttons. This is used for interruption purpose. And also we can see the analogs, analog 1 and analog 2. And also the ports, port B, port C, port D. And also we can see the buzzer. So here buzzer, as my teammate has explained about the working of buzzer. And also reset. This reset button is used for to stop the current working program, and it takes to the starting one. So the time reached 8 seconds. 7, 5, 4, 3, 2, 1. Now I will set the time for 5 seconds.